Hello, everybody. So we are continuing on with optimization, and there is a homework assignment in Canvas. But first, two more problems I want to go over quickly. So first, one of these problems is you're just going to be given the polynomial straight up, and you have to just evaluate it. So this should be the least stressful. So we got Justice Sandra Day O'Connor can throw her gavel at a rate of 76 feet per second. And the height of the gavel will, of course, go up as time moves on, but eventually it'll max out and then fall to the ground again. So, two questions. How long was the gavel in the air with that throw? And three questions. What's the greatest height that that gavel achieved? And how long, or I'm sorry, when did that height occur? When was the gavel at its highest point? So, first of all, how long was the gavel in the air? Well, realize, what is this function telling you? H of t, that's the height of the gavel based on time. Based on time. So when t is 0, this goes away, you're just left with 5.6. That's how tall she is, 5.6 feet. So when time is 0, she has the gavel in her hand and she's about to throw it. And when t is 1, if you that so 1 second into the toss, you could figure out how high the gavel was just by plugging in 1 for t, etc. Well, how long was the gavel in the air? Well, the gavel is in the air until it's on the ground, right? If the gavel is on the ground, then I don't know the time, but I know the height. If the gavel is on the ground, the height is 0. So I'm going to set this equal to 0 and solve. But I'm not really going to do any math. I'm going to let my calculator do all the work. So I just go to my graphing calculator and I type in negative 16x squared plus, was it 76 feet per second? Was that Mrs. O'Connor? 76, yep. And I press enter and I get this. So believe it or not, this is a parabola. It's just the maximum is way up there. So I change my y, I change my window, and we will set this to 100. There it is. So here is the greatest height. So it's important to realize this is not the path that the gavel has taken. For all we know, she threw it straight up in the air and it went straight on down. All we know is that it was in the air, in the air, in the air at these heights, and then eventually it hit the ground right there. So I want to I just remembered, I want to find the when it hit the ground. So I want to find this value right there. And that is a 0. So we're going to our menu, analyze graph, and I'm going to find the 0. Lower bound. So I click to the left of the 0, press enter, and then it's asking for upper bound. So I go to the right of the 0 and press enter, and voila. When x is 4.82, y is 0. So what does that mean? That means 4.82 seconds after she threw it, the gavel is on the ground. So that's how long it was in the air. It was in the air for 4.82 seconds. Now, the second question, what's the greatest height? Well, that is, of course, the maximum. So I would go back here and find the maximum y value. Remember, the y value represents the height, and the maximum y value was 95.8 feet. It went up 95.8 feet. She's got an amazing arm. And that occurred when x was 2.38. So, in other words, 2.38 seconds into the throw, the gavel was at its maximum height of 95.8. So if there are any birds flying around, I hope all the birds are at least 96 feet in the air so they could dodge the gavel. So 2.38 seconds after she threw it, it's at its greatest height. So realize one of your biggest challenges is to, when you have the polynomial, you get to figure out, are you finding a maximum, a minimum, or are you finding one of the zeros? This one is really interesting. there's a line, y equals negative 2x plus 7, and my birthday is March 25th. So there's that ordered pair, 3 comma 25. Now this line has trillions and trillions of ordered pairs on it, doesn't it? It has many, many ordered pairs this on this line. Well, which of those ordered pairs is closest to 325? Seems like almost an impossible venture, but let me get my pen here. It's going to take a while to load, which is always fun. Magic pen. All right, so here's an ordered pair on the line, and I would get my ruler out and measure, try to draw a straight line, measure that distance. Obviously, that distance is much closer than that one. So I wouldn't choose this ordered pair. I would try to choose an ordered pair around here. Like there's some ordered pair around here that is the closest to 325. Not really sure which one it is. It's one of these around here. In fact, it's the one that would be perpendicular. So in algebra, one student could determine this because we have a line. You would find the linear equation that is perpendicular here, and then just figure out what it would be a monster problem, but figure out what that ordered pair is. But the way we're going to do it, we can do this for lines or parabolas or anything. Remember, we're trying to find the distance, the shortest distance between all these ordered pairs and this one. Actually, we just need to find the smallest distance. Distance, distance, distance. Well, do you remember the distance formula? There's a formula that determines the distance between any two ordered pairs. And it's really just the Pythagorean theorem. So it's the difference of the x's squared, the difference of the y's squared. You add them up and you take the square root. So this is the distance formula, and I can give you this on the test. I'm not really concerned about you memorizing it, but so you can have this on the test whenever you want it. But you have to realize what this tells you. This tells you the distance between any two points. Well, one of my points is 325. But the problem is the other point is any point on this line. So can you express all these ordered pairs in just one single sentence? You can. All the ordered pairs on this line, check this out. It has an x and a y. Am I right? It has an x and a y. So the x value is just x. What's the y value? The y value is negative 2x plus 7. You were told what the y value is. Y is negative 2x plus 7. So this ordered pair represents all ordered pairs on this line. Each of these ordered pairs has an x value, which is right here, and each of these ordered pairs has a y value, which is right here. Y is negative 2x plus 7. So now what do you have? You've got 2 points. You've got 325, and you've got this point, x negative 2x plus 7. You plug them into here. You see where the 3 went into x2, and the 25 went into y2, and the x went into x1, and the negative 2x plus 7 went into y1. Be very careful here, guys. You are minusing 2 terms. So when you are doing that, you must include parentheses because you need to subtract both of them. And you don't have to simplify this. This is the hardest math you'll have to do at this point for this section is right there. If you can get here, the math writing part is done. Don't simplify. You are going to your technology and you're going to type this in as exactly as you see it. And to save time, I've already got it typed in, I think on this one right here. Okay, so here is that equation, that function. It's important to note this is the distance. It is the distance between the ordered pair 325 and my line. It is not a parabola, even though it kind of looks like one. And all the y values are all distances. And I want the smallest distance, which is the minimum. So it's negative 6.6 comma 10.7. But what do these two numbers mean? What does negative 6.6 mean? And what does 10.7? You have to, this ordered pair is on this function. The y value is the distance. And the x value is just the x value that's on my line. But the y value is the distance. So I have my answer. When x is negative 6.6, the y value on my line is 20.2. Just by plugging in negative 6.6 into my line, I get my y value. So this ordered pair, negative 6.6 comma 20.2, that ordered pair is on my line, and that ordered pair is the closest ordered pair to 325. How close is it? It's about 10.7 units away. And here is that ordered pair for you, negative 6.6 comma 20.2. That ordered pair right there is the closest to this ordered pair. That's it for this example, but I just want to carry this on just a slight bit further. I went back to my calculator and I typed in when x is 3, the y value, the ordered pair is 3 comma 24. That means when on this line, when x is 3, so that's like about here, the distance between this line and the point, that distance is 24. Because that's what this distance function is telling me. It's telling me the distance between any point on here to this point. This has an ordered pair negative 1, 16.5, which is right here, negative 1 comma 16.5. So when x is negative 1, I'm on the line, but the distance between this point and this point, if you got out your ruler, that would be 16.5. And one more, I put negative 10 comma 13.2. So when x is negative 10, there I am in the line. And from here to 325, that distance right there is 13.2. But all those distances were greater than the answer. When x is negative 6.6, I am 10.7 away from that point. And mathematically, that is the closest I will ever be, that this line will ever be to this ordered pair.